Welcome to the second edition of Can We Talk, the new podcast released by the 2158 FRC Robotics team here in Austin, Texas. I'm your host and interviewer, Gavin Sticker, and will be accompanying you in this podcast throughout our escapades into the world of robotics, FIRST, FRC, and much more for these next few months. I hope you enjoy. Go Cans! Now, as a forewarning, I hope you don't all mind me, those who are faithfully listening to this podcast. I'm a bit under the weather currently, so I apologize for any bad audio. However, I am joined today by Tim Cohn, one of the mentors here at 2158. Tim, would you like to introduce yourself?
Hi, I'm Tim Cohn. I'm a second-year mentor here with 2158. Glad to be here today and get to know everybody in the 2158 podcast community.
Yeah, that's what I like to hear. All right, so the first question I have off the block for you here, if you are prepared,
I hope so.
Is what do you do for your occupation?
Well, I am I'm a global practice director for a company called Quizzitive. I'm the global practice director for what we call our modern work practice. I help companies build their digital workplace, which is the digital equivalent of their global office place, right, for their workers that work both in the field and in the office, right, in the digital space. And so I use products from many different companies, right, to build out digital workplaces for both office workers and field workers where they get their job done, basically. So I tailor computer solutions to people's jobs and help them get that work done.
Very interesting.
Yep, I have teams in South America, Pakistan, India, and the United States, and we coordinate to solve people's problems, which I think is a great job. And it's kind of like getting teams together around the world at first to solve the problem that we get on the first week of every January. So It's a lot of fun. That's
very cool. How does that connect to the world of robotics in and of itself, your job?
It's all about problem solving, right? And I think when I work with my customers, we're usually on a pretty tight timeline. We have a specific problem to solve. There's often lots of rules that we have to stand by, whether it's compliance and governance rules from the government or from the SEC or maybe from the Defense Department or the Nuclear Energy Commission or Federal Energy Commission. And so it's just like getting that 200-page rules manual from FIRST.
Oh, geez.
Yeah, I get those every week from customers, right? And then we have to figure out how to solve my customer's business problem within the confines and restrictions of the rules that are set forward in basically the government's game manual, right? So the training that our participants get in FIRST relates directly to the real world that I work in every day, right? Of just getting out there and doing constrained problem solving. So I love, getting out there and working with these students and then getting these hands-on challenges. Now, the other thing is I work in the digital world, right? And so we, the thing I love a lot about FIRST is that we take these challenges and we build physical things to solve those challenges. And so for me, that's one of the really fun things about FIRST, because it's different. Building a computer program to do something is one thing, and we have that aspect in FIRST as well, is the digital side, but we also have the physical side where we're building the actual machines, right? And we're going full circle with that. So I think that makes it really special.
Yeah, I concur with that. I think if I was in your shoes, I'd be like, okay, I've had enough of, maybe if it was my occupation, I'd be like, okay, well, all day I do is formulate these things on the cloud. I would like to put it down into some physical kind of writing, and I think robotics is kind of a great way to do that, is to manage these problems with, like you said, a 200-page rule book, and instead of it being oh man, that may be illegal. It's, oh man, that may be illegal for a game. And then having to design the robot around that.
Yeah. So yeah, actually getting onto the machines and building the parts and seeing the students put it all together is a really amazing thing to see happen. And then seeing the robots go out and actually compete is the most fun thing ever.
Oh yeah, it's kind of like I mean, I know Asher. I've been friends with Asher for a while. For the viewers or the listeners that do not know, Asher is Tim's son, who is on the team. And I think just like robotics, it's kind of like you get to build a baby. Maybe that was a bad way to put it, but you get to watch it grow. You get to watch it grow and compete, and then it wins, and then you dismantle it and start all over again.
That's right.
But yeah, quoting the great, I forget his name already. We don't use children to build robots. We use robots to build children. That will be a quote forever ingrained in my memory.
That's a good one.
So that is a good segue into the next question, is what has been your major takeaway from robotics, if we haven't already touched on it?
I've had two of my sons go through the robotics program. And I think my biggest takeaway is that you get out what you put into it for sure, but the first robotics team or robotics program, it has something for everyone. First of all, whether you like the arts part of it, right? Whether you like the organizational part of it, whether you're into marketing, right, or designing artwork, or designing or learning how to do project management, or it's not just about the robot, right? But if you're into about the robot, it can be all about that, right? But this program teaches you real skills,
right?
And that's what impresses me most about. That's what I get out most of this from this program, is that of my kids, I think the things that they have gotten from this program, like I have a son who's done 2 co-ops. He's a mechanical engineering student at RIT, and he has done 2 engineering co-ops. And the things that have gotten, one was with a nanoscale 3D printing company, printing. It was a startup that was printing filtration systems for microplastics. And another one, the one he's working for now, is working on hydrogen fuel cell systems and waste systems that are capturing hydrogen from waste streams, hydrogen fuel from waste streams. And both of those jobs he got in large part due to skills that he learned in the FRC program, for both his hands-on skills and then also the mechanical engineering skills he learned in college. But the thing that put him over the top on both of those co-op programs were the manufacturing skills that he picked up in robotics. So I think that's an amazing part of the program.
I think, yeah, I again concur with that statement, because even I joined robotics and I'm like, okay, well, I'm kind of intimidated by, designing or programming or manufacturing because I'm very clumsy and the last thing I want to do is lose a finger. So I joined the business team, and you know what? I'm still involved with the robot, but behind every organization, there has to be a good kind of management of it, and the business team kind of does that. But without, we can't have an organization without a robot, and we can't have a robot without a business team, as I like to say it.
Yep.
So we all kind of have to work together, and it teaches a lot of very, very useful skills. It's kind of heartwarming to be like, wow, that's someone's out there doing such big things after being in this, group or this team. It's, no matter where you go, there's a place for you.
Yeah, and all that work is valued, right? Everybody on the team values each department on the team, right? So it really is helpful.
give or take a few people. Some people are there's some healthy competition between some teams, but or some subgroups,
some sub departments. Yeah,
yeah.
But people don't understand what each department does sometimes until they don't do what they're supposed to do, right? And I think a lot of organizations are like that, but it's yeah. The nice thing is the mentors on this team really reinforce that message, and I think it's important.
You've heard it here, folks. Don't take things for granted. So we've kind of already touched on this, but what specifically do you do here at 2158, and how long have you been here?
So I've been with the team 2 years now, or this is my second season. First season, I worked kind of as a floater, right? I worked with a bunch of the different groups on the team, mostly with the business team, and I did a lot of volunteering at competitions. This year, I focused mostly on the business team, and I also help out a little bit with the manufacturing team. But primarily, I am working on a new initiative that we started sort of at the end of last year. It's through our business team, but it's incorporating all of the groups in our team. So I don't know I know we have another question around this, but should I kind of go through what the pilot initiative that I'm working on, or do you want to cover that in another question?
Well, it's going to lead on to that in a few questions.
Okay. So I'm working on a specific pilot initiative around our circular manufacturing, which we'll get into in a minute. But I mostly work for the business team, and then I help with our impact awards. I help with, because I'm a business manager and I have my MBA, and I have a master's degree in economics, and I have an MBA. I try and work with our business plan and make sure that our business plan is solid. I work with our fundraising and our grant writing. We wrote a lot of grants this year. We continue to write grants. We want to make sure our business fundamentals are solid, and we want to make sure that our team plan for sustainability is, continues to be solid, and that our sponsor contacts are maintained, and that that we're all pulling in the same direction. And so, we have a great group of mentors. So I just help where I can with that, and help with fundraising as I can, and then I still try and help on the manufacturing side wherever I can, because I like to get my hands a little dirty. So I probably stick my nose in there a little too much, but it's a lot of fun.
Yeah, if I had the ability to go and mess with manufacturing every now and then, that would be fun to just mess around with the tools a bit and build something.
Yeah, I try not to get in the way or lose any digits, but luckily we have a very good safety program, and we have some really good teachers at the school and mentors that keep everybody safe. So.
Oh yeah. I mean, so this is my first year at robotics, of course. I didn't even know, I've been to the robotics area before. I was surprised whenever I go in and I'm like, we had a whole, workshop with, machines to mill parts and everything. I was completely just shocked. So, yeah. I don't really know what that has to do, but still, yeah.
Yeah, our Advanced Technologies, our Applied Technology Center is probably one of the most amazing resources that a community can have, and the fact that we share it with the Scouts and with other community groups, and that we use it for outreach is a huge plus for both our team and the community. And the fact that we have a couple of teachers that are supported by the ATC to keep the machines going and to keep building our shop out, and that those teachers support the robotics program is just a real gift.
Right. And that is the main question here, is that we already touched on it a little bit before. But one of the things that you talk about commonly is the design for something that we have coming up called How Circular Is Your Robot? And it is all about, as you said, how did you put it before?
So what we started looking at robots, right? So last year at World Championships, First announced that there was a global aluminum recycling partner, right? And it's really interesting. Novelis, I think it is. And so I judged, I think it was two regional competitions and our district competition last year. And in doing that, as one of the judges, we got to look at many, many, many robots, right? And I was really interested in the amount of plastic, right, that we look at. I have a really good friend who's the global vice president for circular manufacturing at a large plastics company in Houston. He's out of Houston, but it's a global plastics company. They make all the plastic parts for cars for GM. And so, I was talking to him about it, and I actually invited him to a First competition in Houston, and he and his wife came out, and I walked him around the pits, and we looked at the different robots, and he was amazed at what the kids were doing at First. And so we talked about the concepts of circular manufacturing and he got me interested in, and the announcement of a global aluminum recycling partner got me interested in looking at what we could possibly do with circular manufacturing and plastics recycling, right, through First. Because, again, my son was working for a company that was looking at the problem of microplastic solution, right? And we were talking, as a country and as a global community, we were talking about things like ocean plastic pollution and trying to clean up plastic out of the Pacific Mire and all of those things, right? And huge efforts to keep plastic out of the ocean. And I was just looking at the amount of plastic that was on these robots. Some of them were almost completely built of plastic. There was one almost completely built of HDPE or high-density polyethylene plastic. And there's reasons for that, right? It's easy to machine. It can be a great material. It's lightweight, has good strength-to-weight ratios. Has a lot of good materials characteristics that make plastic a great material for robots. Aluminum's great. Plastic's great. Both materials have lovely characteristics for specific parts of the robot. We use a ton of polycarbonate. We use a lot of HDPE. We use a lot of 3D printed parts, right? So we use lots and lots of lots of filament, right, when we build our robots. So as we build these things out, we need to think about and make choices about the materials we use, and we need to make those choices in a sustainable way. Mm-hmm. So we were looking at what is the best way to do this in a sustainable way. And we started looking at, there's a group called Precious Plastics. It's a global grassroots plastics recycling organization. And so we started reading some of those materials, and they have a lot of information on community recycling, right? And so we started to put together the concept of building a pilot program for that. And so that's something that we are working on this year to see if we can come up with both a circular manufacturing program where we look at, there's basically three things. You either reduce the amount of plastic in your initial supply chain, right? You extend the life of the plastics that you use, right? Or you recycle or reuse the plastics that you have used, right?
Right.
And to do that, there's 9 different strategies for that. So when you think about the plastics in your supply chain, you either refuse to use them, right? So you don't use them. You rethink how you use them, or you reduce the quantities of them, right? And then when you're talking about extending the life cycle, you reuse, repair, refurbish, remanufacture or repurpose the plastic that you've used. And then when it comes to recycling, you recycle or recover the materials that you have used, right? So they call those the 9 R's of the circular economy.
Right.
And so when you have those 9 R's in place, and if we put those into the design process of our team, then we start thinking about the circularness of our robot.
Right. All comes back together at the end. And
That's
I
right.
think it's an absolutely amazing idea. I'm, as a person that has been, following these trends of plastic recycling and, the Great Pacific Garbage Patch, which you touched on, and microplastics and all of the whole 9 yards, I think this is a completely, not to toot your horn or anything, this is a completely amazing idea. And whenever I first heard it, I'm like, oh my gosh, I didn't even think of that, but the amount of effort you've put into this is absolutely amazing. How we, I guess I'll touch on it later, but the whole fact of community.
Oops, sorry.
It's all right. You had touched on it before in this book. I was trying to remember how we have the ability to help even not only ourselves with this, but our community as well, because we can take plastics from the community, right, and repurpose that for our own uses and even community uses, such as fundraising options or things like that.
Yeah, that's the interesting thing, is we can not only think about how we as a team use plastic, right, but with some relatively simple tools, right, that the team within our ATC, within our Applied Technology Center, we can build and maintain and use. We could build a community recycling point, right, a center that we, along with some of our sponsors like the Scouts or the Girl Scouts or the school, right, could, or even say some of our friends over at Austin Resource Recovery, the City Resource Recovery Group, could work together to collect clean plastic waste from the community. Things like bottle caps, water bottles, soda bottles from the vending machines in the schools, right? That type of stuff. And this year we've raised about $6,500 from some new sponsors, not sponsored. We haven't had to pull money from our robot budget. We actually raised new money from new sponsors to buy some initial tools, right, to process waste plastic. And so not only are we collecting waste plastic from our build this year, we're starting to collect waste plastic from our team community, our near team community, and getting ready to, our first machine acquisition was a grinder. Mm-hmm. So we have a grinder to grind specific plastics into chips. And then we're building a plastic press, a hydraulic press, we can heat to specific temperatures using a indirect heating element and some steel plate that we run through our mill. And we're going to heat that and press those plastic chips into sheets. And then we can cut those sheets into some items that we need for prototyping. And so we're working on our plastic press right now, using some hydraulic presses that we had in the shop and some induction heaters that we salvaged. So we're reusing other salvage rather than buying new, but we're reusing some salvaged induction heaters that were broken from a kitchen supply store that our electronics people have repaired. And we're going to run those induction heaters through some I-beams that we've milled and heat the plastic sheets and press them into sheets so that we can make some plastic sheets for prototyping some stuff there. And then we can also build like flat pack field furniture and other things like that. And we're looking at building some field furniture for the Boy Scouts and other things like that So some things that we could possibly even sell to raise money for the team.
Mm-hmm.
So we're looking at marketing opportunities, and then our next piece of machinery we're looking at is a possible extrusion machine, so that we can actually mill molds and make marketing materials for the team out of scrap plastic. So we can make little molds for like our mascot. So we can create plastic jewelry out of recycled materials.
Mm-hmm.
Or we could do parts. So we have a new bumper system we've designed this year, which is a really cool clip-on bumper system with a quick release. So you can pull bumpers off, and you can even actually click adjust the bumper height. So it's a very, very cool 3D printed bumper system. But if we wanted to manufacture that, we would want to use induction. We would want to injection mold the parts out of HDPE. And so we could do that with all recycled plastic and make top quality parts. And we could make them very quickly, and we can make them at volume using injection molding rather than 3D printing, and we could use recycled material. So that would be something that we could actually sell and make money on, and it would be good for the environment. So that's something that we're integrating into our business plan.
That is really amazing. Yeah. My main question with that is, how far along are we? I know that you mentioned that we needed the what is it? Not the. Why does it fail to always come to mind right after that you say it? No offense. The mold.
Right. So
if you are at liberty to say, how close are we to achieving this full circle here?
Yeah. So right now we have it's a time thing. The global supply, things like global supply chain and other things are slowing us down right now. So the problem is finding machines that are available and getting those machines over to the United States. Most of these machines that are community level are made in Eastern Europe. And because of the current conditions in Eastern Europe, and there's quite a few of these things that there was a large recycling community in the Ukraine, unfortunately. And there were a couple manufacturers in the Ukraine, and that pipeline for these machines has dried up due to the hostilities over there. So there were some folks making them in Poland too, but that's sort of dried up as well with the influx of refugees over there. So we've got a couple of leads on them in the United States, and so we've even looked at building from a kit ourselves. Build season is taking up everybody's time right now, so I think we're a little behind on the injection molding piece, but we have the business plan. We have a strong start on it. I think we're going to work on we're going to finish the plastic press next. Injection molding is probably something that we'll work on through the summer. And I think we'll have it ready into next preseason. I think we'll be producing prototypes, and then I think we should have it ready for the 2023-24 season, where we'll be able to produce actual parts. So is the goal. But I think the bigger goal for us is to get a pilot results document out and present that to first, because we really want to get, rather than just making our team successful, the key for us is going to be to get a document or a plan produced so that other teams can do this.
Something that we can show off to other people so they can see that this is, we may be taking the first steps into this, but we can start making big leaps into the world of recycling plastics used for robotics.
Yeah, and I think more than that, somebody's got to move first and hit all the roadblocks, right? And clear the roadblocks. And I think that's what we're trying to do is clear all these roadblocks. And then we can create a map, right, for other teams to more smoothly navigate this process and to make it easier for other teams and give them a budget and give them possible funding sources and give them supply sources, and this is where you go for this, and this is where you go for this, and here's a supplier for this thing, and here's things you can make with this, right? And talk to these people about this, right? So we want to make it easier for other teams to start these programs, because here in Austin, we have people have a lot of options when they want to get help with technology, right? In some towns, I think a lot of FRC teams can be a source for STEM technology, right? And so, a small town with a first team could be really a one-stop shop for some great STEM technology, and setting up a community recycling point via the first team, the FRC team, could be a great option for a city, right? And if we provide the blueprint and possibly even a corporate sponsor who could help fund that, that would be a huge step, right, to spreading that message. And so I think for us, it's getting a document that we could provide to first, saying, hey, there is value to this, and there's a way to do it, and see if we could get some help spreading the word and getting the attention of some big companies to help us spread that message.
I mean, I didn't even think of this until now, until you were talking. Especially if we make it more common, it could even benefit potentially low-income communities that don't really have access to programs such as FIRST or FRC, having the ability to reuse parts instead of having to buy them anew every time and come at this huge, deficit of money, and instead be able to do something like what we're planning, and instead turn it into kind of a crutch for our finances on the team. It could help more communities get access to the world of robotics, and especially into STEM with that. And there is a big potential of change here. I don't really know how to put it, but this is something that is big. It is huge in my opinion.
Well, that's something that I pulled from the folks at Precious Plastics. They have business plans for folks to make money, right, to start businesses using recycled plastic. And in many parts of the world, people have started businesses by building the home-built machines that they have plans for, and starting small businesses making bowls and plates and cups and other things with recycled plastic, right? And so in other parts of the world, in other places, right, this type of reuse, right, of a raw material, we could use it on our team, right, to make value-added things from our recycle waste, right? And that helps everybody, right? Because we want to make sure that we continue to perpetually fund the team and keep these opportunities for kids in the school. So we have a really diverse team, lots of income levels, lots of everything. And so we want to make sure we continue to provide these opportunities as long as we can. And so just providing many, many different funding sources is going to always be an option.
Yeah. And you had touched on this earlier about having to convince, everyone that is in charge of FRC and everything like that, the same way kind of recycling aluminum, but now also recycling plastic. Has there been any pushback to your plans? Any just sort of limitations too?
We haven't yet reached out to corporate FRC, right? The big FRC yet. I think we're trying to, I think coming into the competition this year, we're putting this into our Impact Award and into our EI. I think this is a neat and I think an interesting fit into the Engineering Inspiration Award about bringing circular manufacturing and circular design principles into your engineering process. It's something that I think a lot of teams can and should do. So hopefully we'll start to get some notice there, and it's a little bit grassroots. But once we've had some experience doing this, I think we want to see where it's important to get a little bit of market research and some value propositions built, and then we'll talk to First as a whole, and see, or bigger First, right? Mm-hmm. Or maybe First in Texas, and see what we can do there, because I think it is really important, to. I'm sure it's an idea that First is going to want to support. It's such a forward-thinking organization, and they have such a long-term view of the world, right? If they didn't have a long-term view of the world, they wouldn't invest where they invest, which is in young people. So
exactly. And speaking of a long-term view of the world, we've seen the effects of what plastic and plastic waste does to the environment, with microplastics, or even recently the tragedy that happened in East Palestine with the vinyl. What? Oh,
the vinyl chloride spill?
The vinyl chloride spill, yes. And all of that. And I think that, if anything now, this has gotten, and I assume the people that are in charge of FRC and everything like that, are looking at the environment because they're, you know what I mean, because they're kind of helping us children, us kids, to prepare to lead the world in the future, and seeing it being destroyed in the way that is, I'm sure that they've taken notice to this, and if anything now, this is in a morbid kind of fashion, given this a bit of a kick to people that hear it, because the dangers of it have been seen in a very tragedy.
Yeah, well, vinyl chloride is one of those one chemical that's used to make PVC, right? Which is a plastic. Now, PVC is not a thermoplastic, and we mostly use thermoplastics, right? Which are plastics that melt at lower temperatures, like high-density polyethylene or low-density polyethylene or polycarbonate, right? So we tend to use plastics that are that don't need chemical recycling, which PVC is one of them, and that's one of the reasons that we don't recycle PVC, because that vinyl chloride is a son of a gun, that phosgene gas and that kind of stuff, right? So so we really have to be careful about, and that comes into that design decision right at the very front, like how much of a plastic like PVC do you want to use? When do you use it? Why do you use it? How much should you use? How much of that do we want to create? Like, PVC's got some really good uses, right? And it's a really stable plastic, and it lasts a long time, and there's some really good materials choices that, it has some really good materials attributes. And, when a tanker full of vinyl chloride crashes on the side of a rail yard, it can be really bad, right? So we got to be really careful about the design choices that we make that impact the amount of that we produce, right? So, but first, I think one of the things I remember a Woody Flowers speech where, he wants every person in First, right, to get to the position where they can help 10 people or 100 people, right? And so this is another way for us to put ourselves in the position to help more people, right? Mm-hmm. To put each team in the position, or each person in the team in a position to help another 10 people.
Right.
Right. And so I think that's, that should be every mentor's goal, is to make sure that we're preparing each person on the team to put themselves in the position to help 10 more people.
Right.
So I think that this type of circular thinking lends itself towards that type of outcome. So that's kind of why I like it.
Yeah. And I can see always that we're talking here about plastics and plastic recycling. And I didn't know before this, before talking to you, that there is differences in how some plastics are recycled. I mean, it's a given, but if you don't think about it, then you don't realize it. And I think often a lot of people kind of generalize it with, we should reduce the use of plastics. We don't have to reduce the use of all the plastics, but there are definitely plastics out there that can have more consequential effects than others, such as, PVC. It's has a lot of great uses, particularly for plumbing and, kind of industrial work. However, it does come at the cost of it, being very environmentally degrading if there is an accident like this. And a lot of people use it as kind of like a straw man argument. We don't have to get rid of all plastic. We can reuse a lot of it, but it's more of that we need to monitor how much of it that we use and how we use it, because there's always better ways of doing things.
Yeah, I think like our office has gone to a no disposable plastics policy in the office, right? And so, no, we don't have any more disposable plastic cups. We don't do disposable plastic silverware. We put a dishwasher in the break room. You got to wash your dishes, that kind of stuff. So it's those kind of choices, right? Quit throwing stuff away, right? Just wash your darn dishes. So it's a lot of choices like that, right? And that can keep a lot out of the waste stream as well. But I think some of we've tried to do some simple things, like when we cut things on the shop saber, right? Mm-hmm. When you can change your tool paths, right? When you're cutting, say we're cutting polycarbonate sheets, right? Don't cut all the way through into the sacrifice board, right? So cut almost all the way through in the first pass, and the vacuum head, right, vacuums all that polycarb scrap off into the shop vac, and then we pull the barrel off the shop vac that just has the polycarb scrap in it, and we dump that into the plastic recycling. And then on the second pass, we put the clean shop vac barrel on, and then it cuts through, and you have that mixed wood waste. Mm-hmm. And then that goes into another barrel because it has just very little plastic waste and wood waste in it, right? And so then we can just dump that, but it only has a tiny bit of plastic waste in it, right?
Right.
And so before, it would cut all the way through, and it would all be mixed wood and plastic waste, and you can't clean that out. You can't separate the two. So now we make two cuts. It takes a tiny bit longer, but we get clean plastic waste, and then we get a tiny bit of mixed waste that we dump into the wood recycling, and it's fine.
Yeah, and it is just some forward thinking.
Yeah, so we change our cut plans. We change our cut plans for the fiber laser, so that we maximize the use of our aluminum sheets, right? And then we make sure we cut everything up and get it into aluminum recycling. We change the cut plans on our plastics so that we're maximizing or minimizing the amount of waste that we get, right? And we do the depth cut plans to make sure that we're getting clean waste out of the cut, out of those cut plans. And then we do the same thing with the HDPE stuff when we're cutting that on the shop saber as well. And then for school stuff, we built a collection point outside, and then we also built we've scavenged a bar sink, and we built a bar sink outside where we can quickly clean plastic bottles and stuff to get those cleaned out, and we toss them into a collection bin where we can then throw them into our grinder and just quickly grind up all that stuff. So pretty soon, I think at the end of the build season, we're going to refocus. Well, during build season, once we've finished the major build activities and are into drive mode, we'll refocus on building, getting the build out of that finished, and then we'll accelerate the plastics collection. So we'll get it done.
Awesome. I think it is genuinely awesome learning about all of this.
Well, and then the key is going to be writing up the pilot results.
Mm-hmm.
And then I think coming into the season for next year, at the start of school for next year, we'll finish writing up the pilot results. And then, I think we're going to need to make a presentation first and see where we can go with this. I think it's going to be fun.
I think it would be amazing fun. If I was going to be here for another year, I wish I could, but I don't want to do another year of high school. I would love to do another year of robotics. I would definitely stay and be like, yeah, I would.
Well, we're lining up we're lining up the folks for next year, so we'll get everybody going.
That's great. And I know that you talked about even at your work, there's like a zero kind of waste policy where people are even doing the dishes at your work. And so that brings me into this question is, do you have any own opinions, advice of how people that are not in STEM, people that are just listening and they want to live a more green life, how can they help to reduce the amount of plastic waste that they generate and promote a greener lifestyle and a greener culture across the world?
Wow, I think a lot about this stuff, and I don't know that I'm the best example either, but I do try.
Oh, me neither.
But, I certainly try and think about the choices that I make, right? And, it's take advantage of the opportunities that we have to reduce, recycle, reuse, right? Take advantage of the city opportunities, right? Buy local where we can, reduce our packaging, all that stuff. It's a difficult process. I think the things that I guess I tend to see it as an economist, right? You vote with your pocketbook.
Right.
Right. And I do try and support products and companies that are making an effort, right, to reduce their impact on the globe, right? Companies that are packaging better, that are making better products, that are supporting right to repair. City of Austin has a program where you can bring your appliances in, and they'll bring folks in and help fix them. And so they host repair clinics, right? Where if you used to do, that's something that I'm thinking about, seeing if we can get the team to start as an outreach program where we take some of the folks who are good with electronics and soldering and that kind of stuff. Because usually when somebody brings like a broken toaster or something in, it's usually a loose connection or something like that. And if you take it apart, you get a soldering iron out and fix a wire, and bink, all of a sudden it works again, right? Because maybe it's a inexpensive, a manufacturing problem. Not all the time, but a lot of times, I've taken my refrigerator apart 3 or 4 times and fixed various boards and things, right? So a lot of times you can fix appliances instead of throwing them away. And so things like that, right? For people who are STEM friendly, look for opportunities like that in your community, right? Does your city resource recovery group have a repair night, right? Do you have your own soldering iron? Do you know how to fix a toaster or a refrigerator? Go volunteer for that. There's there's a group in Austin called the Yellow Bike Project. They repair bicycles and give them to homeless people so they can get around better. Do you know how to fix bikes? Go volunteer for the Yellow Bike Project in your community or what is something similar to it, right? And fix bikes and give them to homeless people or people who need transportation, right? That type of thing. I think a grassroots commitment to this stuff can really make a difference. So those are the things I think about when I think about, making the world a better place. We have a community here in Austin that builds tiny homes for people that need houses, right? And so I think we've done several projects around there to help repair structures and to make that place, repair fences and put up owl boxes and other things around that through various organizations, including Scouting and others. And, there's lots you can do around that. I think we also went out and put Wi-Fi points around that too at one point. So there's lots you can do around different organizations in your community. So I think, volunteering your time and talents in those kind of places can make the world greener and better.
If there is a will, there is a way.
Exactly.
Now, to get on it's been a heavy kind of discussion that we've had here with recycling and everything, and just how it's a very heavy weight whenever you think about it of all the stuff that we've done. It's a heavy conversation. I'll put it like that. It's a heavy conversation. And as we inch towards the end of this episode here, I just want to ask some more lighthearted questions. And it's, do you have any word of wisdom for those looking to join robotics or are interested in STEM?
Oh man, it's so much fun. We've been talking about a lot of sort of technical stuff and recycling stuff and sciencey stuff, but robotics competitions are just controlled, crazy chaos.
The best kind.
Of the best kind. I have never, every time I go, I'm like, I sort of dread it. And then I go and you have the most fun ever. And it's just like fun and pandemonium and stress. It's like going to a Formula One competition and a rave and a science fair and a trade show all at once.
Oh, wow.
It's just nuts. It's so fun and there's so much energy, and I've rarely seen anything disappointing at a first competition. Almost never. And anyone who has misbehaved at a first competition is always like, it's so disappointing to everyone if anyone does anything that is bad sportsmanship or is not in line with the first ethos. It's just so frowned upon by everyone that it just is such a great atmosphere. So, everyone's accepted. Everyone is welcomed, right? And co-opetition is a thing, right? Everyone helps everybody, and everyone competes. So, man, just go, right? Jump on a team. Get on a team. Participate your heart out. And have fun. It really is. There's something for everybody. I just think, it's probably the most well-rounded school activity. I'm prejudiced about it because I've mentored 2 different teams for 7 years. The that I've been involved, and which means I'm kind of a rookie mentor still, but compared to a lot of others. But it's just so fun. So.
Oh yeah. What would you say is your? I kind of completely am like a loss for words for what you said, because no,
Yeah.
I was gonna move on to the next question, but no,
Yeah,
I
no,
want to
that's all
discuss this. I agree. Even coming into robotics here every day, I'm kind of like, oh man, I don't want to get up at 10 in the morning and go do this. I'm not even at high school yet. Let me just enjoy my weekends.
Yeah.
But then I go, and the moment that I do, there's always something. Someone's doing something, and it's going to make me bust my gut laughing on the floor. And then I'm going to go and get, nagged to do my work, and then I start doing my work, and then someone else does something, and the whole process starts all over again. And it is the most accurate, even though I haven't been to a competition. I feel like the description of controlled chaos, of just pandemonium, is very accurate. And I would say probably the same to anyone that was interested in joining in.
Yeah, it's a lot of fun, and mascots and crazy hair and just watching what people get up to with the robots. I mean, the amount of creativity is just stunning. Creative solutions, creative marketing, creative artwork. Yeah, you're like, how did they think of that? It's just nuts. So yeah, it's a lot of fun. And when you do it year over year, you get why people come back, and why people mentor when they're in college, and why people come back when they're adults to continue to mentor and watch what's going on, because the creativity, the amount of energy is just phenomenal.
And I think that, from an outsider's opinion, this is like me looking out, I think a lot of people would be like, it's a very kind of tight-knit, you have to adhere by these rules, as you said earlier, this 200-page guidebook of what you are not allowed to do. But even though you are constrained to how you build the robot and everything that you do with it, or everything that is allowed to do, it still allows the imagination to run wild in a way that you don't really think of whenever you think of, science or something like that, or technology, where it adheres to the laws of reality, but you still can just do whatever you want at the end of the day. Not whatever you want, but you can do a lot with creative marketing, with creative design choices for your robot.
Well, don't take this the wrong way, but inside every FRC robotics person is a little bit of the evil genius.
Oh, yeah.
Yeah. And so without the rules, I think chaos could reign, right? And so I think the rules are important, right? The rules are important to set that overarching, because it's not that anyone wants to do anything bad, right? And everyone wants to win, and everyone is looking to drive their robot to the best advantage that they possibly can. Mm-hmm. The gamer's going to game, right? And so,
exactly.
And so the people at first try and do a good job of making sure that the game is the game, right? And so they know that they've got all these smart people that are going to try and game the game. And so with all these really smart folks looking at every aspect and every dotted I and crossed T on this whole thing, and yeah, the rules have got to be tight.
Oh yeah, I mean it always.
And so because all these potential masterminds, right, have got to be constrained together in order to cooperate, right? and smoothly, right? And so the framework is really important. And so I think it's an interesting balance that FIRST tries to manage, is the rule versus fun. And I think they do a pretty good job of getting that right every year.
You describing that made me think of a, like that baking soda volcano that you would see at a stereotypical science fair, and you pour in all the evil geniuses, and then you pour in all the rules, and then you just get that right amount of creativity that makes everything just pop and burst everywhere. I think that's...
But it doesn't explode.
It doesn't explode.
Right.
But it gives just a colorful kind of cheeriness to everything. And like you said, everyone's going to find a way to try to game the game. I mean, there comes in the famous question of, is a monkey a legal part for the robot? Which is a genuine question that was asked, for anyone that does not know. It is absolutely hilarious. I think that, it's kind of like a little bit of like a mocking joke, but everyone's there to have fun, and everyone wants everyone to have fun, but at the same time they want to win. And it's a very, very nice community.
It is, but yeah, everyone's going to be looking at the letter, the spirit, and every dimension of every rule.
Oh, yeah.
And some people can see into the 73 dimensions. So, yeah.
It's like cute, happy, cutthroat.
Yeah. Yeah. So n-dimensional rules analysis is a thing at FIRST. Yeah.
Well, the next question I have on here, I don't really have a good transition for it, is right. What would you consider your biggest accomplishment?
My biggest accomplishment is probably getting to the point in my life where I can help other people, which is good. Mm-hmm. I think on the Woody Flower scale, I've managed to get there, which is nice. And getting my kids out the door. Happy to say that, what's that movie, Failure to Launch? I don't have any of my kids living in my basement. My youngest, after he leaves the FIRST robotics team, he'll be going to work on a nuclear reactor in a nuclear submarine. So he's going into the Navy nuclear power program.
Wow.
I've got one son who is going to go work as a chef in a Michelin star restaurant, and I've got another, like I said, who's co-oping as a mechanical engineer right now and finishing his mechanical engineering degree. So I've got the kids kicked out of the house, and so I'm pretty happy about that. It's not a small accomplishment to get your kids ready to launch into their own lives. So pretty happy about that.
I think it's, just like the Woody Flowers thing, having the ability to help, 10, hundreds of people, but then raising your children to be the same way, and then they go out and, they help hundreds of people, but each of them individually do, that's, even more. It adds up, and I think the accomplishment of being a parent I didn't even know that about, I assume it's Asher, that's the one that's going to be...
Yeah. Asher's enlisted in the Navy, and he's going to nuclear power school in July. So
wow.
He'll be doing that. So it's an interesting career choice. He decided on that. As a former military person, I respect that. I don't know. I could never do it.
Yeah.
My claustrophobia would trigger, and I would be screaming in about 5 minutes. But I barely survived a night with the Cub Scouts on the USS Lexington.
Ooh.
But Asher has no problem with that. So, but I think it's really good. I mean, you want to be able to help other people, and I tell my consultants that work for me, it's great to be an individual contributor, right? It's great to be good at what you do, The next step is to be able to be what I call a force multiplier, right? It's better to be able to make other people good at what they do.
Right.
Right? Or make people even better at what they do. And so if you can make other people better, then your own value is multiplied. And so I think that's one of the keys in life, is to make yourself a person who makes other people better.
Right.
So that would be my most proud accomplishment, is to be thought of as a person who made the people around them better people.
That's a very, very kind of noble thing, and I agree with that. And I think that if there was, a national award for being a good parent, I think you would be up there on that list. And that's just an outsider's opinion from only ever interacting with Asher.
Thanks.
And so, yeah. But for the last question up on this list is, do you have any final words to say to anyone, anything, whatever that's on your mind?
If you're thinking about joining an FRC team or a FTC team, do it. Jump in there, have fun. If you're thinking about supporting first, talk to a team, talk to a mentor, talk to a student. It's a great investment to support first, to support an FRC team. You're investing in the future. You're investing in STEAM. You're investing in not just technology, but in problem solving. You're investing in the growth of young people who are going to solve problems in our future. And I think that is critical to what we need over the next 10 to 20 years, right? And to solve some of the problems that we're seeing coming down the pipe. So if you have an organization, or if you are a person who is interested in where we're going, and you have concerns about where our country's going or where the economy's going, hey, you can't make a better investment than to invest in first and invest in your FRC team near you, because it's a great way to invest in the future. Cool.
Well, I thank you very much for joining me here today, Tim. I think this is going to turn out to be an amazing episode, even though we're not technically done yet. But I would like to shake your hand and thank you for coming on and letting me interview you. It was very nice talking to you.
All right. Thanks.
Thank you for tuning in to this edition of Can We Talk? We here at 2158 thoroughly appreciate you for your time and support. If you're interested in learning more about us and what we do, feel free to head to www.andersonrobotics.org and make sure to check us out on Instagram at FRC2158. Have a wonderful rest